Now let me go back over to the syllabus. Okay, so laptop, desk. So yes, make sure that you have your personal laptop in case when you're taking your quizzes, you always want to be doing it on the computer. If you do it on your phone, you might mess up and then you say, oh no, hey Scott, I messed up on the quiz. Can I get a retake? I'm not the professor. You can ask Dr. Rastogi if something happens like that. But unfortunately, you got to follow the syllabus, use the laptop whenever you take your quiz. Be really diligent and double check your work every time that you perform it because it's an online class. Sometimes it's easier and sometimes it's harder with this. And like here, the cam scanner, you can use it on your cell phone to upload your lab notebook if you do a physical one. And yeah, so the face mask that doesn't apply to us because we are not in person. But if you are sick, you should contact Dr. Rastogi regarding that, in case maybe you need to like get some sort of extension or something, just in case. And if you are sick, also please do try to attend to kind of clarify the information within the experiment for your own benefit, because it is difficult when you are sick. But fortunately, we do have the technology. If you just need to turn your camera off for the day and you just need to lay in bed and listen to me just walk through the experiment for you, then that works too. As long as you're here, that's 90% of the participation. So yeah, you can review any of this information going through. Make sure to download this syllabus. Let's see. So yep, all of this generic stuff. Go ahead and jump down. So details for teacher running lab experiments, they are in Canvas. Always look into Canvas. There's a lot of information in there that we can, look through that can help you out. That maybe, if you don't open it, you probably won't know what's going on in the class. And you might ask me a redundant question that can be answered by opening up the files. So let's see. Yeah, I will be making announcements every once in a while for critical information on Canvas. Let's see. And yeah, you can post general questions to each other within the discussion section as well. Make sure that you are here for the lab period. Fortunately, it'll only be about an hour a week. It's much easier than having to be in a lab for 3 hours and standing there doing your experiments. So please, please, please be on time and be around. Okay, so this stuff doesn't apply because we're not in lab. Keep going forward. Okay, so an important thing is that we're going to have to make sure here before the lab day, read the experiment, review the experiment and the module. It'll show you some videos. I'll click into that after we get through this and show you guys where that is. Complete the pre-lab quiz by Friday and make sure that you start up your pre-lab notebook before you come into here. And then the notebooks, they're going to be due on the Sunday after lab is done. So this coming Sunday, your lab notebook will be done. So on lab day, you come in here, attend the Zoom meeting, ask me any questions that you'd like for clarification in the situation of our experiment. After lab day, complete your notebook and then submit only one PDF. Make sure that everything is bundled together, like I said. So if you have multiple parts, use some sort of program that you can so that you can combine everything into it. Let me see, I have a chat. Hold on one sec, it's messing up. So the pre-lab quiz will be due the Friday before lab. And so you were saying you can't find the notebook for this lab. Okay, so I'll show you guys that here after we get through this syllabus. Let's go ahead and keep moving forward. Okay, so this part is not applicable. Most of this is not applicable to us because we're not in lab. So this part right here is very important. Make sure to review this because this is going to be exactly how to complete your lab notebook. This is a full overview of it. This is the part that I want you guys to have done before you jump on here at 3:30 on Tuesdays. Title, purpose, apparatus, instruments, hazards, pre-lab, calculations, and procedure. Then afterwards, you'll get your data, you'll analyze it, and then you'll complete the section here. So let's see. So with regards to here, Dr. Rastogi says that late submission is not accepted with the lab notebook. So make sure you get it in by, I think it's midnight on Sundays. Yes. So for experiment 2, the pre-lab quiz will be due on the 5th. I need to speak with him because some of these quizzes, they have the wrong due date on Canvas and they're open until like the 12th. But, just make sure to go ahead and get it completed sooner than later so that he doesn't close them because they are supposed to be due on the Friday of the week before the lab for the next week. And then, the same thing, the notebook was due the Sunday after that we complete our Zoom meeting. So here's our grading policy regarding participation for today. The main thing will be attending here. That's a big part. You don't have to worry about the punctuality attitudes, safety cleaning up, punctuality. Make sure you show up here. Be attentive. Try and ask me questions while we're in here. Type it in the chat so that way that we can figure this out. Because maybe maybe you have a question that somebody else has in their mind, and maybe they don't know how to phrase it or they're afraid to ask. So always feel free to type in the chat or speak up in here and ask a question if you want to. As well, make sure that you complete your pre-lab quizzes before the due date and on time. Early is always on time, so that's very important. Same thing right there. The online lab notebook, make sure it's submitted by the Sunday before the following Zoom meeting. And we will discuss the ChemX discussion and poster as we get closer to that date, so just so that way we can save some time here and actually get into the experiment that we have for the week. And so let's see. So the exam, it will be on our lab day. I'm pretty sure I need to double check with him. And it would be 2.5 hours. It'll be an overview, I would assume, of the whole entire semester. And this is the requirements. You'll need to have a laptop or desktop and a cell phone, so that way that they can do like a monitoring. You'll see in the next picture what I'm talking about. So group C, make sure you have your Texas State ID, driver's license, or passport to show your photo ID proof. The cell phone will be used as a scanner to scan up the document that you're going to use as your photo ID proof. We're going to use the examity proctoring, and then that's the duration there. So this is how your camera will be set up facing, so that way that it's watching you as you're performing the exam. And then this is the grading scale that we'll be using for the lab. Here's the drop day, drop policy, and we already had Martin Luther King Jr. Day. So spring break, March 15th through the 19th. Remember, we will not be meeting on that Zoom day. Okay, and anything in here that you need to review, always feel free to either email me or Dr. Estogi, and we can, figure out the situation that you have a question about. I've been getting tons of questions left and right. So if I don't answer immediately, just give me a little bit of time and I'll try and get to you as soon as possible. Okay, let's go ahead and go down. Yeah, and again, absence, if you're absent during the Zoom meeting, I do take attendance every time that we attend. So just make sure, if you are absent, contact me or Dr. Estogi regarding that. The vehicle thing, not an excuse for the Zoom meeting. You can always just jump on your phone. And I of course do not require you to do a camera unless we need to share the screen to show your pre-lab was completed, or if you need to do the camera to show me, your physical lab notebook and I can take a look at it. Okay, and then finally, if you need to look and if you wanted to theorize what your grade will be, this will be the outline of how to create a calculation. So that'll be on page 15 of your syllabus. You can plug in all of your scores here, and then you can do a theory of what your score is. And remember that your lowest report is dropped and your lowest quiz is dropped, and lowest participation. Well, if you're here 90% of the time, you're going to get participation. As long as you completed your pre-lab notebook and you have a little write-up for me to check and I see it, then you're good to go. You're probably going to get 10 points. If you don't do the pre-lab notebook and we're 4 or 5 weeks in, it's been pretty far in. If we were actually in the lab 90% of the time, you probably wouldn't even be able to go into the lab, because you need to have the safety data written, you need to have the experiment written. That's just the formality of it. But fortunately, we do get to drop the lowest of each one. So if you need to take a look and see an example, please look at pages 15 and 16 to calculate your grade. Now, finally, and this is also uploaded separately, is our schedule here. This week we'll be doing recrystallization and melting point, next thin layer, TLC and chromatography, fractional distillation, simple, et cetera, et cetera. So every time before, read the manual, brief overview, watch the videos in the module. We'll jump over to that here in a second, and complete the pre-lab quiz / your pre-lab notebook. Come into the meetings, be prepared. If you have questions, good thing to do, write them down so that way that you remember what you need to ask. So that way, you know, if you're like, oh, I had a question, it's always good to just write it down, you know, make a note in your computer or on a little sticky note so that way that you remember that, and that way you can ask me and not forget it. So yeah, this is going to be our schedule for the year. This is here in the syllabus and also on the Canvas portal. So let me go ahead and find here. Let's see. I'm going to go ahead and navigate over to Canvas here for 1 second. Yes, so the pre-lab quiz will be due on Friday, and the lab notebook itself will be due Sunday. Second lab is after recrystallization. Quiz is also due on the 5th. The lab notebook will be due on Sundays, and the quiz will be due on Fridays. Currently, the quizzes, they have different turn-in dates. I would try to do them as soon as possible, though. You know, just use your manuals as review towards them, and you'll probably do fine. So it looks here that your quizzes are available until February 12th. So, I mean, you guys have a really large amount of time until next Friday. And I'm not sure if that was accidentally labeled for February 12th, but normally that would be February 5th for the recrystallization, then quiz 2, that is labeled correctly, February 12th, and then the following one is the 26th. I'll have to speak to him regarding this. It looks like the due dates are all over the board on the actual quiz itself. Yes, so these are all going to be uploaded onto Canvas or through announcements. I'm gonna have to figure out a way to upload them because I think that the files only have a certain amount of gigabytes of storage on Canvas, but I will upload these afterwards. And so the quizzes, the only curve that we will have on quizzes is that the lowest one will be dropped. Otherwise, there is no other curve that will be on there. So let me go ahead and open up here the module section so that I can show you guys where to go. Let me take a look. So it looks like on here that the quizzes are available until February 12th for quiz 1 for this lab and quiz 2. I would get both of them done by this Friday because I need to contact Dr. Rastogi because he informed on the syllabus that they are due the Friday before the lab. However, it looks like that they are open to an incorrect time. So I would have both this quiz for today's experiment and the quiz for next week's experiment completed by Friday, just in case you don't want him to close it out and then you miss out on a grade. So let's move forward into reviewing. Let me share my screen real quick. Okay, so when we look over here, you can see under modules, it'll be right here, experiment 1, recrystallization and melting points. Make sure and go ahead and watch all these videos. I'm not going to take the time today to watch these videos with you because one of them is 40 minutes long. It's better for us to walk through the manual and review that together. So that way that you get, you know, the deep information. And then this will be a very large understanding of exactly how the experiments, you know, are performed. So make sure, 1, that you read the manual, and we're going to go ahead and go through that here in a moment. Then secondly, watch and learn all of these videos here. Thirdly, complete your pre-lab notebook, which is, you know, what you should have done currently. And then fourthly, complete your pre-lab quiz. let's see. Okay, now let me switch back here for a moment. Let me see. Yes, so post-lab, so your whole lab notebook for your recrystallization and melting points experiment 1 should be uploaded and due by midnight Sunday. The pre-lab for experiment 1 should be done today. It should have been completed. And the pre-lab for experiment 2 will be due next Tuesday when we perform our Zoom meeting. The pre-lab for the experiment for the week needs to be done before we meet here on Zoom. Let me go ahead and open up the recrystallization here for you guys, and we can walk through that one next. Okay, and this is the important thing that we're going to perform here mainly, is that I'm going to walk you through the manual so that way that you guys can get a deeper understanding, because everyone learns differently. So we're going to highlight the most important thing here. So within recrystallization in itself, we're going to go forward and look to see, what exactly is recrystallization? Well, recrystallization is the act of taking a pure compound out of an impure compound or mixture. So the idea is that in this experiment, we have copper sulfate and benzoic acid, and we're going to want to separate them. The idea of a pure compound would just be benzoic acid alone or copper sulfate alone. Now, how do we perform the recrystallization? The way that we perform recrystallization is that we mix our mixture into a solvent, and the solvent needs to be mostly soluble for one part of the mixture and insoluble for the other part of the mixture. So if we take a look here, and I'm going to scroll in so that way we can see it a little closer. We see here in this table, and this is for any organic or inorganic compounds. There are solubility tables across the board that will explain to you the solubility at a given temperature. Now, solubility increases with temperature. So for instance, if you try and put salt into cold water, you would have a very, very low amount of salt dissolved into the water. However, when you heat it up, then you would have a larger total amount of salt dissolved into the water, just as an example. Now, if you take that, hot, very full salt solution of water and you put it in the freezer, then you would recrystallize it. The salt would actually come out because there's only a certain amount of grams per liter that can be dissolved at a given temperature. And we'll review that further when we go down into the chart. So looking here, water is a great solvent here for the mixture because, as you can see, that 32 grams of copper sulfate can be dissolved into water at 20 degrees Celsius, which is near room temperature, whereas only 0.27 grams of benzoic acid can be dissolved. As we increase the temperature, however, then benzoic acid can be dissolved easier, and that is part of the experiment that we would be performing, would be to take benzoic acid in a mixture and dissolve it into water, and then we would heat it up and it would completely dissolve, and then we would cool it down slowly. The idea is also to very slowly cool things down so that way that the crystalline structure can actually compose. And that would allow us to obtain the benzoic acid out of the compound mixture, because as you can see here, it only has 0.27 grams allowed to be dissolved at 20 degrees Celsius. Now, if we wanted to do the opposite and have copper sulfate fall out of the solution, then we could do something like have it in ethanol, because as you can see here, benzoic acid is extremely soluble at 20 degrees Celsius. However, copper sulfate is not soluble at all. You would also, have different sort of solvent systems that you can work with in an organic setting, where you can, have a benzoic acid and maybe a benzoic ester that you wanted to separate, and you could use a mixture of ethanol and methanol at 10%, 20%. That's the main methods that we use in our lab. We do ethyl acetate hexane mixtures in order to change the polarity, and that way we can separate one compound from another compound. So that's the idea that we're kind of getting here today, is that we can use different solvent systems in order to firstly dissolve a crude mixture, and then secondly to pull out our pure product of what we want out of there. And then going forward, melting point, it's pretty straightforward. Everything has a melting point and it turns from solid into liquid. So the main thing that we are going to be looking at is different sorts of mixtures. So benzoic acid and acetanilide mixture, benzoic acid and benzamide mixture. And if you want to see images such as right here, the structure of benzoic acid, always just feel free to Google and you can see the images of these different compounds. Some of them are very similar, some of them are not so similar. So let's go ahead and go forward. So here is the graph relative to what I was speaking about earlier. So when we look at something like solid A and solid B, and we have them into a mixture, then we create this chart here that is a separation of solid A and solid B. And here at the eutectic point, this is important because this is where both of these together, if you were to bring the temperature to this point at a composition of 40% of B and 60% of A, they would both simultaneously melt and become a liquid solution. If you increase the temperature high enough, pretty much anything will melt, especially with regards to the products that we're using here. So the main thing is to understand that mixtures have a eutectic point regarding their composition, and there are different points here along the axis with regards to the composition of compound A and compound B. So the objectives of the experiment, if we were to be performing this in lab, would be to recrystallize a sample of contaminated benzoic acid, with our copper sulfate and our benzoic acid in water. Secondly, we would want to characterize the compound by melting temperature analysis. So knowing that the melting point is at a certain temperature for each compound, we would note, oh, okay, this is benzoic acid. Oh, wait, no, it's at this point. Then it's going to be our acetanilide. And then finally, we would identify unknown samples by melting point analysis, which is effectively the same situation, except for using an unknown. So now here is the procedure, and this is what you'll want to have completed within your lab notebook. You would weigh out your contaminated benzoic acid sample, and then you would weigh it, transfer it to the beaker. So here is a good example right here that you guys should look at for regarding the solubility. 25 degrees Celsius, that's kind of near room temperature. 95 degrees Celsius, extremely hot, near boiling. So only 2 grams per liter at 25 degrees Celsius is the amount that would be dissolved of our benzoic acid. However, when we heat it up and we start stirring it and heating and stirring, it goes all the way up to 68 grams. And it might be like an abstract idea to you of what is 2 grams versus 68 grams. So if we think about it in terms of pounds, 2 pounds versus 68 pounds, if you think about those two, that is a very large difference. And then when you cool it down and you bring it back down to 25 degrees Celsius, you would basically, if you had 68 grams dissolved, for instance, 66 grams of benzoic acid would fall out of the solution. So then here you would want to do a calculation to see how much liquid that you would need in order to dissolve the benzoic acid. We would heat it up, start stirring. Let me take a look here and see. Yes, you'll want to use the calculations will be basically you'll use an estimate by using calculations using the numbers given here. Yes. So then, we would go forward and heat it, stir it, and then on the side we would prepare an ice bath. The ice bath would be used in order to cool down the solution and precipitate out our crystals. So then it's dissolved. We remove the flask and the hot plate. Then it would cool down to room temperature. And also that's another thing in lab, and you probably know this, that people have told you before, never take something that is extremely hot and then put it into something extremely cold because the glass will shatter. So that is one safety tip that you should know as well, just in your daily life. So one tip that we can use is to scratch the bottom of the beaker with a glass rod in order to start causing the crystals to start precipitating out of the solution. And so, yeah, so here, if you were to reduce the volume of the solution by heating it again, basically what you're doing is you are reducing the total amount of water available for the entire solution. And then that would basically decrease the solubility of your benzoic acid because you'd have less liquid in the system to dissolve it. So if you have too much water and then you just put in a random amount of benzoic acid, then most likely it'll dissolve. But if you have a very small amount of water, then it'll have a very low chance of dissolving. So we go forward, then after it's cooled to room temperature, then we put it into the ice water bath, and that's where the real precipitation would start occurring. You pretty much go to the maximum amount of precipitation. Then finally, you would set up a vacuum filtration, and you would set it up with a ceramic filter that is attached onto glassware. And I'll open up another file here in a moment to show you that Dr. Rastogi provided for us. And you would put a filter paper on it, and then you'd run it through like you were making coffee. The liquid would go through, or the water and the solution, and then the crystals would stay on top of the filter. So this part here is very important, and this will be part of the data that you guys will obtain here. Be sure to record the mass of the filter paper before placing it in the vacuum funnel, because what happens is you take the filter paper, then you have your pure compound on top of it, right? Well, how do we weigh it? You take your watch glass, you go over to your scale, and then you tear your watch glass. Well, you didn't weigh your paper. So now all of a sudden you have crystals on this paper and you don't know the total weight. So you need to make sure that you weigh the filter paper, and the filter papers, they're made industrial. So the thing is that one filter paper can be 2 grams, one can be 5 grams. It's not really a standard cut and dry amount for the weight. So you would weigh your filter paper, and then you go perform the experiment. Get your crystals on the filter paper, dry it, make sure that it's as dry as possible because water can also skew the weight. Then you go forward and you would weigh the crystals on top of the filter paper on your scale. Going forward, then you would save the solid for the melting temperature analysis. So the capillary tube, it's basically like a glass tube. And what you would do is you would place some of the solid into the glass tube, and then you take the glass tube and you put it into a melting point apparatus, or melting point machine. Sorry for using that word. No, it confuses y'all. Put it into a melting point machine, and then you would look through a glass and you would look at the temperature and see it as it rises. And then slowly you would see the solid start to disintegrate and turn into liquid. And then once you see it turns into liquid, then you have yourself a melting point there. So don't worry about the printing copy of your graph and such. That part's not relative to us. You guys will get data, and I'll show you guys where to get that next. So here's our data table. Make sure to either put this into your Microsoft Word document or into your lab notebook as a way to put in all of your data that you will be given. You put it here. And then I think that there's only 4 unknowns given in the Excel document. So you can just go up to the 4th portion right here, and then the benzoic acid as well. And then here are your final questions for the lab notebook at the very end. So 1 second, let me go ahead and pull up over here. Oh yeah, the file. So I will go ahead and pull up the file now that we can look through. Let's see. Yeah, so Caleb, I see what you're saying here. So I was informed, because this did happen to a couple students in the other lab, that if that's the case, what I'll do is I'll go ahead and give you randomized data, and then that way that you can go forward and use it for your calculations. So let me go ahead and pull it up here. And I'm going to share my screen briefly so that way you guys can see where to access it. So whenever you go into Chem 2141, go into Files, go to Lab Data for Students, then come here to Experiment 1 Recrystallization Melting Point, and then you will see the data. You go ahead and download the data, and then you can pull off the data specifically for yourself. Please let me know either now or as soon as possible, if you are not in that Excel sheet, and I can get you your data, because I know it's going to be impossible to work on it without having your data. So let me go ahead and take a look here and pull this up for you guys. Excel sheet here, share. Okay, so as you see here, whenever I was talking about the filter paper, this would be really important in the lab because, for instance, so like Sarah, hers here is 4.2789 grams for the filter paper, right? Well, let's come down here, and this Jennifer, this person's is 3.2789 grams. So you see that's an entire gram of difference. That can really, really skew your data, especially for the fact that we only have a certain amount of milligrams of the pure benzoic acid that we'll be pulling out. So if you were in lab, you would always, always, always make sure to weigh your filter paper and write that down. And make sure that you use only your data for your calculations, because that will be used for me to grade, your calculations performed. So let me go ahead. Okay, Dwight, I'm gonna add you as well. Okay. Okay, so yeah, if everyone can go ahead and just double check into the Excel sheet, make sure you have your data. And if you have any further questions, go ahead and either speak up now or go ahead and type into the chat, and then we can move forward and try and tackle those. Let me take a look at my notes to see if I have missed anything here for you guys today.
Okay, so before each lab, we do the pre-lab and the quiz, and then come to lab Zoom and we go over it together, and then we do our calculations separately later, and the post lab and everything.
Right. Yeah. So effectively, the way that we're going to look at it is that the data that you use, that we are given on Canvas, is as if that you went into lab and performed the experiment the day of. So okay. Yeah. So we'll take all the data from the Excel sheet weekly that we're given, and then you'll go forward and use it for your lab notebook calculations.
Okay, thank you.
Okay, so let's see. There were questions from lab 2 in this. Yes, so I was noticing that there were questions from lab 2 as well, and I'll need to discuss that with Dr. Risto because there's a little confusion regarding, I think that I was told from the last section that something regarding chromatography or TLC was mixed into there. And so, yeah, I'll have to discuss that with him further. Is the notebook graded on completion? Yes. So, it's just graded straight off the rubric. Always feel free to review the syllabus if you're a little confused. Always also feel free to email me if you need clarification. And if we can't clarify it over an email, we can meet up on Zoom and have a little quick chat, so that way we can, have a more effective communication than over text, because sometimes it can be a little confusing. With lab notebook, can we take a picture of our worked out lab notebook, or do we have to scan them? So according to the syllabus, it is stating that we need to have this into PDF form. So if you can take a picture and then convert it into PDF somehow, maybe using Google Docs like somebody was speaking about earlier, that would be an effective way to do it as well. Or yes, as what Emily is saying on the Adobe Scan app is free, so you can utilize that as well. Yeah, so any method that you can use in order to obtain the PDF to upload, any sort of app or anything like that will work out. And yeah, so Sarah's saying an iPhone as well. Okay, let me go ahead and double check that I have everyone accounted for in attendance here, so I don't miss anyone while we kind of start wrapping things up, and if anyone has any extra questions here. So the hazard section of the notebook, do we have to make a chart form of it, like the template, or can we just write it out? So whichever way that works for you, you can do either or. That is a personal preference, as long as that you have effectively the template, like put the things there that are critical for the hazard section listed out within the syllabus. So that way that in case, one person has like an extremely a really vast explanation of hydrochloric acid, and it's a 3-page explanation of it. Okay, sure, maybe don't do that. Give me like a couple sentences at least. I'm not going to be too particular on, oh, you need to list out an entire page of how hydrochloric acid is dangerous. Give me some brief overview of it, and then we'll be good to go. And yes, so the best way to reach out for me is by my email, slb232@texasstate.edu. So always feel free to email me on there, or and if we can't get it resolved in an email, then we can go ahead and make a Zoom chat, and we'll speak it out there. Let's see. Making sure I have everyone accounted for here. Okay, so it looks like we don't have any questions going forward. I'm going to finish up here, make sure I have everyone that is logged in here accounted for. I don't have the best attendance system here, so it is a little confusing. Okay, so it looks like we don't have any further questions, but if you do, please pop them in the chat before we end up the day here. Yeah, and feel free to, work together, make sure that, that your notebooks are individualized, do not copy each other's, work. That's technically plagiarism, but, if you guys need to work to, get through the problems together, that's fine. Just make sure that your lab notebooks are individualized and legible. For changes to the procedure in the notebook, do we have to, for changes to procedure in the notebook, do we really have to add anything? I mean, no, if you can find an optimization of a method, you can add that in. Okay, so I will go ahead, and today it'll just be as an example, just to see. I'm going to type in a few names here into the chat, so that way that we can review the pre-lab, and then maybe even people can just take a quick view on some people's here. Okay, so the names that I typed here, if you guys can go ahead and either share your screen with your Word document to show your pre-lab, or show the physical copy of your notebook for your pre-lab. That way that we can go ahead and have that as part of the kind of ritual of attendance.
Yes, I have my pre-lab on paper. This is the copy of the actual lab notebook.
Okay. Okay, yeah, that looks good.
It says that you disable screen sharing, so I can't share mine.
Okay, what did you say, Taylor?
Sorry, I typed mine up on a Word document, but it says that you disable screen sharing,
oh, yeah,
so I can't share it.
Okay, so Savannah, you're good. Felicity, you're good. Madison, you're good. Let me see. The only ones I have left are Pedro and Nadia. And then let me go ahead and have the share screen. Oh, should be a way to multiple participants. Okay, so yeah, if you can go ahead and. Okay. Okay, great. Yeah, so guys, if you can see here real quick pre-lab, this is a great example here. Just, do your purpose, apparatus, instruments, hazards, and that's pretty much good to go. It's a brief overview. This is how it would go if we were in a lab. You would just, show me real quick. I would go, boom, take a look at it. Great, you got it written down. That's awesome. The main thing for a pre-lab is for you to understand the experiment when we walk in, and then have it ready to go. So if anyone's missing their pre-lab notebook, today will be your free pass. I was informed to, let you guys kind of learn what we need to do. And then from now on, if you don't have your pre-lab notebook, you will be taken, part of your participation grade will be removed. I'm not going to be too harsh about it, but just make sure that you show up ready for class and have a brief overview. That's okay. We'll go ahead and move forward. We'll just have it as an example for today. This will be the free pass. And then for next week, make sure, guys, that everyone has your pre-lab notebooks ready, and we'll be good to go. So if we have any further questions, feel free to stick around and go ahead and either ask me or type it in the chat. And if otherwise, then you guys are free to leave, since we kind of sat around there for a bit. So thanks for coming in, guys. I'll see y'all next week.
Thank you.
Yes.
I had a question.
Yes.
I'm sorry, I just cut somebody off.
Okay, go ahead, Katie.
Okay. So just to be super clear, what should we have as the pre-lab calculation formulas that we're using? Because I don't want to get anything wrong.
Okay, so the pre-lab calculation formulas, you're saying for this lab or in general?
Yes, for this lab. Because
So go ahead.
Just for calculating the water that we needed and the other calculations.
Yeah, so you'll want to do the calculation of the solubility of benzoic acid, and that will be one calculation. Another calculation would be percent yield. I think it is, let me see exactly what it is here.
I had it in my brain.
Yeah, mass of recrystallized product. That would be the
Right
yield from after you remove the crude from the mixture. A percent recovery. That's the phrase that they use.
Okay.
Yeah, so that would be that would just be you can put your the formula down for percent recovery because there's nothing that we would do before we go into the lab, to perform the calculation. So if you just go and look through the full entire experiment before we go into it, just write down any of the important calculations. Most of them will be conversions or yields. So most of it's, it's going to be very minor calculations that we'll have up there.
Okay, thank you.
Okay.
Scott,
Yeah.
I had a question too. The data analysis, is that the same thing as the post-lab questions?
Right. Yes. So the data analysis is the post-lab questions. So that way that you go forward and you analyze the data that we had obtained from the lab. Yes.
Okay, awesome. Thank you.
So the turn-in process, so like Adriana was saying, the data analysis, oh, sorry, you can't see me. The data analysis is our post-lab, but our actual, I guess, lab part that we're turning in is just going to be like the data tables, like filling out the data tables.
Yeah. Yeah. So you fill out the data tables. If you have to write up, you'd write up the full procedure, and then the data tables. You'd act as if we were just in the lab, and you obtained the weight of your benzoic acid. You obtained the weight of your unknown 1, 2, 3, 4. So yeah, you just take the data from the Excel sheet and you place it into there. Okay. Does anyone else have any questions before we head out for the day? Okay.
I don't think so.
Okay. All right. Well, feel free to email me if you guys have any questions, and have a nice day.